Please remember there are additional resources and things such as code samples at elithecomputerguy.com. So if you're watching one of these classes and you need to know what code looks like, or if you need links to the resources that we're using, please go to elithecomputerguy.com and take a look at our class posting there. Also, please remember that free to the end user classes are not actually free. It costs me a lot of money to be able to provide this type of content. So if you could click on the donate button and throw in a couple of dollars every month, this will help me be able to continue to provide you this type of material. Welcome back. As you know, I am Eli the Computer Guy, and today's class is going to be about using the OS module in Python. So it's very important to remember as a new programmer that all programming languages have been designed to solve specific types of problems. Just like you would not use QuickBooks to write a term paper, although I suppose theoretically you could, you also wouldn't use the wrong programming language in order to solve whatever problem it is that you're trying to solve. So the reason that we use Python, the reason that Python is amazing and exciting and great for the modern world is because Python is a language that allows you to go out and connect to other people's services and also interact with the underlying operating system in order to perform certain tasks, right? So basically you can literally have, your computer go out to a web page with Python, scrape all of the information out of the web page, then format that information, and then save that as a file directly onto your Apache web server so that, basically you could copy somebody else's web page without all of the ad tracking and that kind of thing, right? That's one of the things that you can do with Python. But that's what makes Python really, really great. Basically, you can just put it on your server and you can have it go out and be able to interact with all kinds of different resources. In a previous class, we used the requests module, and the requests module allowed us to go out and access what are called REST APIs to be able to get information from the world around us. We were able to get our external IP address. We were able to get weather reports. We were able to get detailed geographic information about where our computer was located, and we were able to do that all through the requests module. So what we're going to be doing today is we're going to be using the OS module, and the OS module is going to allow us to interact with the underlying operating system that our script is running on. So if we want to create directories, if we want to delete directories, if we want to use the tools that are installed on our operating system and basically be able to get the results from those tools being used and do something with them, that's the type of thing that we will be able to do with the OS module. Again, one of the big problems that we have with noobs that get into the technology world is they want to reinvent the wheel. And then they want to do that like 50 damn times a day. And they have no idea why they're not getting ahead, right? Like there's this weird thing like with the like new coders, like there's new technology professionals and old technology professionals. And new technology professionals will tell you how they will only write their own code and they wouldn't use anybody else's, and that's the only way to do it. And then you have the old technology professionals that are like copy, paste, copy, paste, copy, ship. Right? And basically, what you find out in the technology world is there is just no reason to reinvent something that somebody else has invented. The other thing that's also very important is a lot of people, don't understand how certain programming languages do certain things, right? How can PHP or how can Python be able to determine if web pages are up? Like, how do I actually write that full script? How can I have my Python script do some kind of, Metasploit or some kind of hacking services or whatever else? This seems very difficult to figure out how to do that, but it becomes much easier if you realize, no, there are already Linux packages, or God help you if you're using Windows packages, that allow you to do a lot of things at the command line, and so you can literally have Python interact with the operating system, run command line commands that already exist, nmap, ping, traceroute, whatever else, they already exist, be able to get back the response from those commands, and then do something based off of those results. So again, you're not reinventing the wheel. So we're going to be dealing with the OS module today. And again, this is really, really, really cool and allows you to do very powerful things. Now, warning, Will Robinson, I do have to warn you of something. You might actually have to know operating system command line commands in order to be able to really do something of value with the OS module. Again, when we start getting like new technology professionals or new coders, they come to me and they're like, Eli, what is the one language that I need in order to get a job? And then I just look at those people and then I groan. And then I mutter about really needing a beer right now, right? There's this idea like the one language shall unite us or whatever, and that's just completely and utterly not the case. Whether you're doing old school sysadmin work or network admin work or programming, the reality is you're never going to be using one single thing. You're going to have to understand a lot of different skill sets. Previously in these Python classes, I've shown you things like HTML, right? You can actually have Python dynamically write web pages. Well, in order to do that, you need to know HTML and you need to know CSS. You might want to know some JavaScript. Again, knowing database, access would be a useful thing, right? In order to build that web page, right? I can show you how to write text to a file. You have to figure out what text it is you want written to the file, and again, what problem that text is supposed to solve. Again, with the OS module, when we're using the OS module, many times we're actually going to be sending commands directly to the operating system, and then again, we're going to be reading what the results are. Here's the thing. You're going to need to know what those commands are, right? Whatever it is that you're trying to solve for. If you're going to do traceroute, you actually have to know the command for traceroute. Again, ping today. Ping is very interesting. So we're going to do an example with basically a network monitoring type script at the end. And an important thing to be thinking about is in the Windows world, when you run the ping command, the computer will ping the host 4 times and then stop. Or at least it did the last time I used Windows. It's been a little while since I've used Windows. Anyways, it would ping for 4 times and would stop. That's a nice default that Microsoft has. And the interesting thing is when you use Linux or when you use Mac OS, so I use Mac OS, if you do the ping command and you don't put any additional arguments in, it will just literally keep pinging until you force it to stop, right? So you actually, and I'll show you, you have to do ping space -c for count 1, actually tell it only ping once, and then whatever host or IP address, it will ping once and send the response back. So the 2 things you have to remember here is 1, you have to know what the hell the commands are. And 2, if you fat finger something with those commands, you could run into a problem because, again, with Python, with the OS module, basically you're going to run the command, and then when the command finishes, the response will be sent back. Well, what happens if you run something like the ping command without that -c, the count of 1, so it just keeps pinging forever? Remember, it will only send the results back once it's finished. If the command that you sent to the operating system has no natural end, that's one of the things that can lock your computer up. That's one of the things you'll hear about things like with leaks. So we don't have leak problems the way we used to. Back again, I got my MCSE in 2000. Windows 95, Windows 98 had these things called memory leaks. Which was sucked, right? Basically, whenever you run a program, whenever you do anything, the system has to allocate space in RAM for you to be able to perform whatever tasks that you're doing. And then once that task is finished, it's supposed to release that memory space back to RAM so that it can be used for something else. One of the issues that you run into, or you used to run into, is what we're called memory leaks, where basically a program would request an amount of RAM, the program would finish, but it would never release that RAM back to the operating system, and then it would run again and need more RAM and never release it, and then need more RAM and then need more RAM, and you would actually have your system crash because you had this memory leak where it was constantly gobbling up RAM without releasing it back to the operating system, so the operating system didn't see it as available RAM, and suddenly you take up all your RAM, not actually doing anything, right? Leaks can be a problem. Again, one of the things you need to be thinking about with Python, again, if you're sending commands to the operating system with no natural breaks, is especially in a production environment, could you have some kind of leaks where you start burning resources? And again, at scale, one user does it, who the hell cares? 10,000 users somehow trigger one of these events, your system can go to hell. Again, imagine if you run a command for some reason, let's say you're doing network monitoring, and so you go out to ping. And so you have one user that goes out to ping, but it never sends back the results. Well, that just kind of sucks for the user. Yeah, well, they're users. But then you have another user do it, another user do it, another user do it, you have another user do it. If you do not have any kind of garbage or cleanup routine going on, all of a sudden you may have 10,000 users that triggered ping commands that are never stopping. Again, the ping command on its own doesn't require very many resources, but you get 10,000 people all running ping commands at the exact same time. That can actually burn up a lot of resources, and that's one of the things that can slog your server or your system down. And it's just, again, one of those things, just to keep in mind. The other thing today is I'm going to be showing you commands, and these commands will work in Mac OS, and these commands will work in Linux. So again, I would argue if you need a lab computer and you don't want to buy a Mac, use Ubuntu. It is a great lab computer. But do remember, Mac and Linux use different commands than Windows does. So things like ls space hyphen l, right? List the directories or the list the files and directories in a directory, right? In the Windows world, that would be dir. So one of the things just to keep in mind with this is if I'm showing you commands today and it doesn't work on your particular system, you may actually need to use, different commands, and you need to go and do some Google research to figure out what it is, right? I can only do so much in a video. The final thing to say here is you may be asking, why are we not using the sub-process module? So again, one of the big things to think about in the Python world is there's 20 different ways to skin a cat. There's 20 different ways to basically accomplish the exact same task. And so sub-process module does most, if not all, let's say most of what OS module does, and it is considered the better module, right? By people who say things like better modules. So why aren't we using the sub-process module? Again, one of the things you have to be thinking is about, for me doing these kinds of classes, I try to simplify everything as much as possible. And so previously we've used the OS module. I think the OS module comes up by default much more than the sub-process module does. And so I'm just kind of going with the flow, continuing to build on what we've learned before and make this as streamlined as possible. You may find when you go out to do your own research, sub-process is actually a very good module. There's a lot of good reasons to use it. And you might be like, oh, why the hell am I using the OS module? I should use the sub-process module. And that's fine. I'm not saying that the OS module is better in production. I am teaching it here because I think it's easier from an educational standpoint. And again, that's one of the big things you have to be thinking about as a new programmer. You will hear a lot of people tell you about what the best way to do things are. And again, yeah, you have 10,000 servers and you're making $250,000 a year and you have all the resources in the world. Yeah, there's definitely ways that I build stuff in that particular environment. I'm sitting in a cement room talking into a camera, trying to explain to people in Africa how to code in Python. So I'm going to try to keep this as simple as possible. Again, use cases, environments are very, very different. So these are just some things to keep in mind before we get into this class. Now, the first function that we're going to go into in the OS model is the system function. So the system function is very cool because basically what you're able to do is you are able to send a command directly to the operating system. Again, do you remember this is going directly to the operating system? So things like security permissions might come up. So we talk about permissions, read, write, execute in the Mac and Linux world, and the 510 permissions that Windows probably has at this point. So again, this is where it can get a little complicated for when you're trying to do something. Any command that you're going to run, your user account has to have permission to run that command, and that's a whole kettle of fish that we're not getting into today. I have many classes on Windows and Linux and all that kind of stuff if you want to get into that if you're having issues. Hopefully for this particular class, everything should just run smoothly, but I say that as hopefully. So basically with this, the first thing that we're going to do is we're going to import the OS module. So the OS module is considered part of the standard Python 3 library, so that you should not have to use pip3 to install it. If for some reason you don't have it, use pip3 to install it. I do apologize. Our last class we did the request module. Apparently the request module isn't part of the standard library. You do have to actually install the request module. It's kind of one of those things I got confused. I just use it so often. I thought it was always on the computer. And I was wrong. But anyways, the OS module should be part of the standard library. Then we're going to create a command. So I find this easiest, again, when you start programming, using variables with their values is a lot better many times than simply plugging in what the variable value is in a function. So this way you can modify the variable value once, and then that can be reused throughout your script. So we're going to create a variable called command. It is going to equal touch space os-test.txt. So what the touch command does, and this literally simply creates a file. You'll do this sometimes when you're setting up platforms or whatever else. You just simply need files to exist. You don't need anything in them yet. They just have to exist in order for your code to run properly. And so the touch command in Linux or in Mac OS will simply just create the file you tell it to create, and we're going to create os-test.txt. Now we're going to be running this, and again, with Python, your default working directory is going to be the root directory for your user account. So we are in the Eli home directory, and we can see we do not have any text files here currently. So what we're going to do here is we're going to do os, so os, the module, .system, the function, command. So we're going to be running this command, and then that's it, right? We don't have any equals or anything yet, so we're just going to run the command. When we run the command, we're not going to get any results down here because we didn't ask for any results. But if we go over, we will now see that we have os-test.txt. So we were able to send a command directly to the operating system. So this might be useful for you in the real world. Again, touch is actually something you use in the real world. But if you want to trigger, let's say, other scripts. So let's say you have one Python script and you want to trigger other Python scripts to fire off. You could do Python 3, whatever the script name is here, and it will do whatever it's supposed to do. So let's say your script is monitoring like temperature levels for CPUs. If the value goes above a certain amount, trigger a Python script to send out an email blast, and then that Python script will send out the email blast for you. So again, you can use this to run again things like touch and ping, LSL, whatever. Standard commands, but you can also use this to do things such as trigger scripts in Python 3 or something along those lines. Now, one of the interesting things here, if we go down here, I will uncomment this out. And so you can get a value back when you send the os.system command, right? So when you use os module, the system function, and you send the command, you can actually get a value back that you can print out. The thing is, when you do this, if it works, you will get a value of 0. Do you see that? So if your command works, you get a value of 0. If, again, and this is the cool part about just using that, the value for command, if you run this and you screw it up, this is the operating system sending back errors. The main thing that you get though is this number here. So 32512 is the error code for when you try to type in touchy or whatever instead of what you were supposed to put in. Now, theoretically, you can put these error codes into Google and try to figure out what they mean. I mean, you can. You can. Oh, the results that you'll get back. God bless you. You can figure out what the hell they're talking about. They will very thoroughly explain something that is very difficult to understand. So one of the things you can do, again, if you're using if-else statements, that type of deal, is simply do a statement that says if. So we have the result here. So what you could do is if result does not equal 0. do something, send a notification, whatever else, so it equals 0, do what you're supposed to do. So that's one thing that you can do with a system. So you're not actually getting back the results from the command. So if we did ping here, we wouldn't actually get the results back. So if I did, let's see, ping cnn.com, right, for the command, and I run this, oops, look at me, see? I did something stupid. See, this will continuously run until I stop it. Let me kill that. -C1, so let me ping cnn.com once. So I do this, it goes through, and then we get the 0 number down here. But if I did ping like that, screw that up instead, command not found, and again we get that 32512 error code. So you can use that error code in if-else statements to trigger events if there is a type of failure, but just realize you're not actually getting the response back. You did see that ping command show up on the screen, but it's important to understand that's only showing up within the command line. That's not really actually showing up within your Python script, if that kind of makes sense. So anyways, that's what the system, the OS system function is, and this is a incredibly valuable tool. So now we get to a function that is arguably more useful than system, right? So system is going to send the command to the underlying operating system, and it's basically going to work or not. If it works, you can get a response back of 0. If it doesn't work, you can get a response back of basically gobbledygook. There's not a lot you can do with that. Again, you can do an if-else statement based off of 0, but that's about it. That's where the popen function within OS comes in and is very useful. With popen, you're able to run a command, but you actually get the operating system response back, and then you're able to parse that response or do something with that response, right? So we're going to have command here. This is going to be the command, and the response is basically going to equal that command that's been sent, and we're going to be able to print that out on the screen. Now the script is a little bit more sophisticated than what we've done in the past, because again, we're what are we, 14 lessons into the Python series, and so I am going to start adding little things that we've learned before. So if you just jumped in to this series, of this particular class, there might be some things you don't understand. We talked about a lot of this stuff in previous classes, but I do want to build up your skill levels as we go, and so we're actually going to be using the input function today. So instead of just statically assigning something like an IP address or host name, we will be able to manually plug it in for every time that we test this particular script. So anyways, with this, we're simply going to import the OS module, as you do. Host. So this is who we're going to be pinging. It'll either be an IP address or it'll be a host name, fully qualified domain name, CNN.com, FoxNews.com, whatever, MSNBC.com, Breitbart. Whoever you like, I don't care. I've just been saying CNN for 14 years. It's kind of funny. Again, in the YouTube content creation world, you start saying something 14 years ago. And when I started saying CNN.com 14 years ago, it was not a controversial thing to say. Anyways, I keep saying it because I'm a geek and I just keep doing what I do. Anyways, so host is going to equal the input function. And then we're going to say host / IP address to ping. So this is going to show up on the screen and it's going to say, what host or IP address do you want to ping? The command is going to equal, using the F string to make life easier. And so ping space -c space 1. So we want a count of 1. And then we're going to plug in that host that came in from the input function. Response is going to equal os.popen command read. So it's important to understand, in the Python world, everything is an object, and especially when you send like commands and get results, those are going to come back as objects. And so if you just simply try to print out the results of os.popen command, down here, you're just going to get an object value. That's really not going to have any use for you. So you do the .read at the end, and this is going to pull out the text that comes back from this popen function so that we can actually print it out on the screen. So we can print it out on the screen, or we can do if-else statements based off of that information, that whole 9 yards. So do remember the .read. If you forget the .read and you print this out, you're going to get the arrow type things, and it'll say something about being an object. object, and it is not going to work for you. So that'll be the issue. So anyways, so this is all it is. So basically we're just going to ping the host or the IP address. We're going to read that value into response, and then we're going to print out that response. So let me run this. So I run this now, and again, we're getting something that's a little bit more dynamic. Host IP address to ping. So I will say cnn.com, because I'm a rebel that way. I'm so punk. I still care about CNN, sort of. Anyways, I hit enter, and so this is the result that we get back. Ping cnn.com, and so on and so forth. If I then go on the exact same thing, and I say fox.com, it will then print out the results of fox.com. And so this is all the information that comes back from the ping. And again, pretty simple. The important thing to be thinking about here is, again, everything in here can actually be parsed. So if one packet's received, you can do something. We're going to be doing that in a demo later. We can then, you can use regex. So regex is a class we're going to be doing about 10 classes from now. It's called regular expressions. You can go in and grab out specific values. This is latency, right? These are latency values. So you could actually bring this in, use something called regex to pull out latency, so that not only would you know that you can communicate with a server, but you would know how fast you're communicating with the server. You can pull that kind of stuff out. You'd be able to pull out the IP address if you cared, all of that kind of stuff. Now I will show you, again, if you forget the read. So if you forget the read, right, I just do this just to show you how this works. I go here, I plug in cnn.com because I'm a rebel, and this is the response that you get. os.wrap close object at blah. Right? So you get back that object value that is worthless to you. You need to have that .read at the end in order to turn it into text. And so this is an important thing. Again, we went over this in the requests class, the last class that we did, is many times when we run some kind of commands, again, the OS module or the requests module or whatever else, we're going to get objects back. And so one of the things you might have to do is a little bit of Google searching of figuring out how to turn that object into the text that you care about. Like when we use requests, text comes back as an attribute, so you can simply do period text, T-E-X-T, nothing else, and that will pull the text attribute out for you and give it to you. On the other hand, if you need JSON, you use a JSON method, so it'd be .json with the parentheses, and that would then get the values and then format them as JSON values so they can interact with it with JSON, right? That's what you have to do with the request module. In the os.popen, at the end we use a period read parentheses, and that gives us the text from the response. With some of these, there's also things like read lines if you want to create a dictionary of lines from the response. And so again, it's not complicated. It's not complicated. You just might have to do a couple of minutes of Google search to figure out how do I turn the object into the text that I care about. Now let's talk about the path function. So the path function is very valuable because it allows you to start interacting with your file structure in a more nuanced degree. We actually talked about os.path, I don't know, 5 or 6 classes ago when I was talking to you about how you can try to save files into specific directories or save files into the same directory that your script is running in, right? So if we go and we take a look at our operating system, one of the problems that you might run into with your Python script is whenever you go to write files or whenever you go to read files, your Python script is always going to go to the working directory. And so generally, unless you modified it, the working directory is going to be the user's home directory. So again, when we do a lot of these Python classes, you'll notice even on my Mac, we keep coming back to the Eli directory. And in this is my home root directory. So whenever I write a file, I create a directory, whatever else, using Python, it will always get dumped into my user's root directory. If I go to read a file, and I'm not very specific click on where that file is located, it will by default go to my user directory, my root directory, in order to try to find that file. Now, a lot of times, just simply to make sure that a script is functioning, that's fine. It's no big deal. But one of the problems that you're going to run into is many times you want the files that your script is going to be dealing with to be all within the same folder. Right? You're going to create a folder with your script. You want the log files or whatever else saved in that folder, and you want to be able to read directly from that folder. And so that is where we're able to use the path function within the OS module to both get the directory name of where this script is currently located, and then based off that, be able to save into the same path, basically using join. So let's take a look at this for a second. So what we're going to be doing is we're going to be importing the OS module as we do. Directory equals os.path directory name, dir name, and then within parentheses, os.path absolute path of this file, right? So this is a default value for this current file. So when you do __ file, that's this file that I'm currently in, and the absolute path, so this is getting the absolute path for the operating system of where that file is located, and basically all of that is going to go into directory. Now what's important here is using this dir name is this will format this for whatever operating system your script is running on. Now again, remember with Python 3 can run on Linux, it can run on Mac, it can run on Windows, it can run on a potato. But how file structures are formatted on different operating systems might be slightly different. Again, / versus / that type of deal. So instead of just hard coding in and writing in how this should be on Mac OS or Linux OS, where it might not work on Windows because the slashes are different, by using this os.path.directory name, dir name, this will format it simply so that whatever operating system your script is running on, it will work properly. It'll put in the proper slashes. It will put in the proper formatting. And so that's one thing to think about. Again, one of the big issues that we run into is that whole thing in the technology world of it works on my computer, right? You sit there, you spend a week, you spend a month coding up a project, you package it up, you send it out to the client or the user, and then it doesn't work on their server. Why? Because you're using Mac and they're using Windows. And so even though everything that you're doing is really simple, it should work properly on Windows. Simple things like this, you may have hard-coded in file paths, and those file paths look good on Mac or Linux, but don't work properly on Windows. That's why you use this type of thing here. So anyways, from here, we're going to print out the directory. So we're going to print out what our current directory is. Then what we're going to do is we're going to save a new file into the directory, right? So basically this directory that we've created, what we're going to do is we want to save a new file into the directory. So the file name here and the directory here, and we use the join command in order to do that. So directory name, dir name, that gets us where our file is located, and then os.path.join, what this is going to do is this is going to marry the directory path with the file name, and by using join, we're going to, again, format it properly for the operating system. So basically, when you do join, you put the directory in first, and then you put the file name, and it will super glue that together. So this is going to be the file path here. What we're going to do down here then is we're going to say with open file _ path. So we're going to open this file that we just created the path for here. W, so overwrite as file. Then we're going to do file.write. The OS module is cool. So into that text file, we're simply going to write this particular phrase. Then, because we're using the with open, it'll automatically close. We do not have to close it. Then we're going to go down here, and we're going to say with open file _ path R for read, again, as file, message equals file.read, and then we're simply going to print the message out here. So if we go over, and again, we go to my file directory, and we're at the OS module, we can see I just have the scripts for the day. I don't have any text files here. Can I increase the size of this? Well, I increase the size a little bit. If you can't see it, take my word for it. Anyways, so now what I'm going to do is I'm going to run this script. And down here, we're going to see the OS module is cool. So it created, right? It found out what the current file path is. It has the file name. It married those two together. It wrote into file path this message here, and then it was able to read and it was able to print out. So if we go over, we'll notice this was what I highlighted before. So we have os-test.txt. That's the file that got created. If I double click, again, you can kind of see the OS module is cool. So it was able to create a file in the directory that the script is located in. It was able to write to that file. It was able to close that file out, and then it was able to read to the file in that particular directory. And so this can be pretty useful for you because, again, like with this, right? So this is printing out what my file directory is, right? So when we print up here, we print directory. So you'll notice this is an ugly directory, right? Because I use iCloud. So users, Eli, library, mobile documents, comp, app, clouds, documents, OS module, right? That's where this file is stored. So I don't want to have to type that in manually because I definitely will fat finger that. So by simply using this up here, it's able to grab that, and now basically I can dump everything into one folder and have my scripts be able to interact with the documents and everything in that folder. So this is the path function within the OS module. Again, directory name basically gets you the directory name formatted for your operating system. Joins the directory name with the file name, again formatted for your operating system, and then with that file path you're then able to open files, read files, do whatever it is that you need to do. Now let's talk about the OS module functions that are available in order to do pretty routine maintenance tasks on your system. Now, as I've talked about before, right, whenever you're going to be sending commands to the operating system, you need to be making sure that the commands that you're sending to the operating system are the right commands for that operating system. If you send Linux commands to Windows, it's probably not going to work. And if you send Windows commands to Linux, it's definitely not going to work. And you can run into a mess that way. So one of the cool things with Python and with the OS module is there are actually a tremendous number of basic tasks that they have functions for that will simply work regardless of the operating system that you're using. So if you want to make a directory, so you just want to create a directory, right? Whether it's Windows, whether it's Linux, whether it's Mac OS, using mkdir, that will simply make the directory for you. You do not have to worry about the underlying commands that make that function. If you want to rename, if you want to remove directory, if you want to scan the directory, if you want to do a number, just a tremendous number of things, there are all of these built-in functions, right? So basically we have the os.make directory down here that creates directories. And if you scroll through, there's a lot. There's a lot. We're not going to go through all of these today, but you can do change mod. So if you want to be able to change the mode, basically the permissions for a file, you're actually able to do that through a Python function. You can change directory, you can change ownership. Oh, you can do so much stuff. So if you're interested in this, again, W3 Schools has all of this information. I'll put a link on the Eli the Computer Guy webpage so you can take a look at this more. But basically, if you have the option of whether to actually run a specific operating system command or be able to run a Python function, it is much more appropriate to run the Python function because therefore if your script, again, goes onto a Windows server or to a Linux server, make directory, it will simply allow that to happen. So with this, the first thing we're going to do is we're simply going to do os.mkdir. Now you'll notice we're not using the path function here. So when I create a directory, that is going to be going into my root, my user's home root directory, again, just to make sure that this isn't too complicated. So we're going to import os.mkdir test-dir. So we're going to create the test-dir directory. I'm going to run this. I don't get a response down here because I didn't code any kind of response. And as we can see up here, we now have test-dir directory. Woo! I know, it's exciting. Look, sometimes I got to teach you boring crap. You got to learn the boring crap before you get to the cool crap, which you'll then realize is kind of sort of boring. Anyways, so okay, from here, what I can do is I can then, so I'll comment out the make directory. And so what if I want to rename? So I don't want it to be the test directory. I want it to be the not test directory. This is going into production. We're being professional here. So literally os.rename, it'll rename this directory to the new name. So if I run this now, I hit run, don't get a response because I didn't code it. I come back here and now look at that. Not hyphen test hyphen dir, it has been renamed. If we want to go down here and we want to remove it, again, with remove, there's a couple of different remove functions. Make sure you grab the remove function that you need. os.rmdir for remove directory. So we're going to remove the not hyphen test hyphen directory. And we're going to run that. And then we're going to go. And we can now see it's no longer there, right? So that showed you how to make a directory, rename a directory, and remove a directory. I'll get rid of that. And then the next thing down here is we can actually do a scan directory. So what the scan directory is going to do is it's going to scan the folder for everything in the folder. It's going to give a response that we can loop through with a for x loop. So results equal os.scan the directory. So whatever the root directory is, since I don't have any additional path here, for x in result, print out what the result is. So I'm going to do this. And so now we can see on the screen, we have everything, interestingly enough, including the hidden stuff that is in this particular folder. So hidden config, music, iCloud Drive, hidden DS store, hidden, pictures, desktop, library, right? So it allows you to scan a directory, pull those values out, and then do something based off of those values. Again, the important thing with this, the most important thing is not these particular functions, is just thinking about when you're writing your code, it is much better to use the built-in Python functions to do these types of tasks versus hard coding in specific command line commands, because again, if you dump it onto a Windows system or you dump it onto a different operating system, you'll get a failure. When you're building your projects, again, one of the things I've talked about before is that you always need to be thinking about maintainability, right? So when you leave the company and somebody has to take your project over, are they going to understand what the hell you're doing? That's one of the things that you have to be thinking about, and that's why you try to create clean, concise code that makes half a bit of sense. That's why syntax and styling matters. The other thing to be thinking about too is what happens if your code becomes very, very important for your company. And so over the years, your code may stick around as hardware and as operating systems get upgraded, right? So you may create some kind of, maintenance code or something that does its nice little task, and it's still working great 10 years from now. Well, one of the things to be thinking about is what happens if the next version of Windows has different command line commands. So there's something called deprecation. So in the technology world, what deprecation means, or something is deprecated, basically it is something that used to exist but was pulled out of the latest releases of the product for whatever reason. You'll hear about deprecation a lot, especially in programming languages. As new versions of the same programming language come out, they'll say the previous functions were deprecated, they weren't secure, they weren't efficient, whatever else. Here's the latest way of doing it, right? So if you hard code commands for what the operating system is supposed to do, and Windows or Ubuntu or somebody else deprecates those commands for whatever reason in the next decade, right? Those hard-coded commands then are going to fail, which is going to be a misery. On the other hand, right, if you use, the built-in functions that Python has, then even if the old way of doing it gets deprecated, the old specific commands get deprecated, the functions should get updated as time goes by. Because remember, Python is an interpreter. It's actually a program that gets updated just like QuickBooks gets updated, just like your operating system gets updated. So when they have another version come out, they can update their functions to work properly with the latest commands on the operating system, and that will make life easier for everybody. Again, one of the important things I really want you to be thinking about when you're designing your projects is it's not simply about giving the project to the customer or to the client or to the user right now, you also need to be thinking about 5 years from now. Are you designing your project so that 5 years from now, again, maintenance or whatever else, it was designed in such a way that it is maintainable? So that's something to be thinking about with everything that you do. And now we get to the final lab for this particular class, where again, we try to create something that at least simulates solving a real world problem. This is something that you need to be thinking about whenever you're learning how to program or do anything in technology. At the end, always sit down and build something that at least tries to simulate solving a real world problem. So we're going to be creating a network monitor today. We're going to be able to input a number of different hosts or IP addresses. And basically what our script is going to do is it's going to continuously ping those hosts or IP addresses to tell us whether the site is up or not, right? So let me just run this before we get into the script to kind of show you how it's supposed to work. So I hit the run command, and what you're going to notice here is it's going to say hosts and IP addresses to test. So it's multiple. So I can do cnn.com, I do fox.com, I can do 192.168.1.1, I can do 192.168.1.55, and I can do Bob, right? So fully qualified domain names, IP addresses. So this is a good IP address. That should be a failure. And then Bob, which is neither a fully qualified domain name or an IP address. So I'm going to hit enter. CNN.com is up. Fox.com is up. 192.168.1.1 is up. It's going to go. So it's timing out because .55. So that is down and Bob is down. So basically it's going through, it's pinging. If it's up, it tells you it's up. If it's basically down or unreachable, it tells you it's down or unreachable. It pauses for 2 seconds and then it repeats. I'm going to show you how to do this today. So let's go and we can take a look at this. So we're first going to import the OS module. As we have been, we're also going to import the time module because we're doing a while true loop. We're doing a loop that continuously goes until we hit Control C. And so we're going to need the ability to sleep. So down here between each loop, time.sleep function of 2 seconds. I don't know, just to make this a little better, maybe we'll go to 5 seconds here. Okay, then we're going to do sites. So the sites are going to equal the input function, and this is going to be what the prompt is. Once we have sites, so when this comes in, it's going to be a string. So a string is just a long line of text, right? So we need to turn that string into something that's actually useful. I can't ping a whole long line of text. That's not going to work. What I need is a list so that I can iterate through the list in order to ping each item in the list. So sites equal sites, so that site string dot split. And so what we're going to do is we're going to split that string. The split method splits a string into a list based off of a specific character that you set. And so a single quotation mark space, you may not see this, there's a space between these double quotation marks, right? So when I type in cnn.com space, fox.com space, Bob, right, there's a space in between. So based off those spaces, it will then find the space, and then those will be each items in the particular list. And then just for troubleshooting purposes, you can print out the sites here just so you see what's going on. We're going to have that list. Then here, what we're going to do is we're going to do a while true loop. So a while true loop is a loop that never stops, right? It just continuously goes. You'll hear me talk about this with API calls where, God help you if you're getting billed and you get a while true loop, because a while true loop is something that continuously loops. So if you're getting billed a penny every time the loop iterates, it's going to get expensive shockingly quick. Anyways, if you're not doing APIs and if you're not getting billed by it, while true loops are just fine. But do be careful if you're using while true loops and API calls. That can be dangerous. So the first thing that we're going to do is we're going to do os.system, and then we're going to send the clear command. So this means on the command line, we want to delete everything that's there, right? So this is going to iterate. This is going to do the pings, and then I want it to clear, and then do the pings and want it to clear, and then want the pings, do it to clear. If I don't clear, basically it's going to have the pings, and then the next set of pings, and the next set of pings, and the next set of pings, and it's just going to keep rolling down the page. Putting the clear here clears the screen like you normally would, because again, that's just simply a Linux command. For address in sites, so we have that sites list. We're going to say each index value is going to be called address. So we're going to try, and again, we've done those try accepts. So again, whenever you're doing API calls, whenever you're dealing with the operating system, you should do try accept, because if you try to run a command and it fails, and you don't build this whole try accept thing in there, your entire script is going to fail and it's going to go to hell. So what you want to do is you want to try to run the command, and then, right, if the command doesn't run for some reason, you want something else to happen here. So we're going to do the try statement. Command equals f ping space -c for count 1 of the address. Response equals os.popen command.read. So basically, we're going to get the value of the ping command, and then we're going to read it into response. Then we're going to come down here and we're going to do an if statement. Now, this is an important thing to be thinking about, again, when you're dealing with operating systems. So what we're going to be looking for is if one packet's received in response, print the address is up, else print the address is down. Now, do remember, different operating systems respond in different ways, even for something as simple as the ping command. So I was writing one of these scripts when I was doing the in-person classes here at Silicon Dojo, and again, this is all very, very simple stuff. So I didn't worry about typing it out on my Mac and then just deploying it to the Linux computers, because obviously it'll work. All I'm using is the ping command. How could there be a problem? I forget exactly. The issue is so if one packet's received is in response, right? This happens, else something else happens. So in Linux, it's if one received in response. So one packet's received is not in the response, because that is not a Linux ping response. And so I had written all of these scripts. I threw them onto the Ubuntu demo machine right before I was supposed to do class that night. All of my scripts were failing miserably, and I was about to lose the very little hair that I have left. I was trying to figure out why. And the reason is because in all my scripts, the message was if one packet's received, and since it was Linux, that wasn't the response that was coming back. It was one packet's received, so all of my stuff is failing. Again, this is the kind of thing that you have to be thinking about as a programmer, as a technology professional. You would be shocked at how many stupid little problems there are out there. And so again, you got to modify your code for your particular environment. And again, that's also one of those things I was talking about with the built-in functions in Python. What makes those so nice is if you can use a built-in Python and function in Python, then you don't have to worry about these weird, syntax quirks that you might run into. So anyways, if you're using Linux, you're probably going to do one received and the response. If you're using Windows, I don't know what you just do the ping command and basically see what a good response is. So anyways, if one packet's received in response, print the address is up. Else, print the address is down, except, so there's some failure in this mess, print address command failed, and then we're going to sleep for 5 seconds. Pretty simple here. And again, it's a while true loop. So it'll sleep, it'll go to the beginning, it'll clear the screen, and then it'll go through. Clear the screen, then it will go through. Again, if I go run this, I can then do cnn.com, msnbc.com, and Bob. All right, so I do this. cnn.com is up, msnbc is up. You get this, cannot resolve Bob, unknown host, Bob is down. And then it's going to loop after 5 seconds. You see how it blinks? That's when it's actually doing the loop. Up, up, down. Now here's the thing. Since this is actually running on the command line, this response here, this ping cannot resolve Bob, unknown host, is actually simply a command line response that's coming up. This is not a value that you can currently use in order to trigger an event to happen. So you may not want this to be there. And so one of the things that you can do then, in order to stop this, Control C stops. And one of the things that you can do is if we change response, right, so we're going to do this instead. And again, this is where you start getting into the whole command line things. So before we had os.popen command read. That's all we had. Now what we're going to do is we're going to do os.popen. We're going to use an f string command space 2. what is that? Lesser than slash dev slash null. So what this is going to do is it's actually going to output that return value that you're seeing, that failure value. It's just basically going to flush that value down the toilet so that it doesn't show up on the screen. And then we're going to read, right? And so basically that makes the whole user interface a little bit better. So again, if we do, let's say Fox this on fox.cnn, fox.cnn. Fox.com and CNN.com and Bob, right? Now we just see, since we're sending the response to null, we're flushing it down the toilet, Fox.com is up, CNN.com is up, Bob is down. Right. And so this gives us, a little bit nicer user interface to be looking at. And again, that's the kind of thing that you need to be thinking about as you build your projects is how can you clean up the outputs just so it's easier to see. This gives you the exact same information the previous, version did, but it gives it just in a more streamlined, easier to understand fashion. So there you go. Now you understand about the OS module in Python. To be clear, there is a lot more to this module than I showed you today. But again, that's the kind of stuff you can go and Google and you can play with on your own. This is relatively simple. The main thing to be thinking about when you're using different functions, again, whether you're using the system function or the popen function, think about what you need to do. The system function allows you to send a command directly to the system, and the only response you get back if you want it is simply 0 that it worked, or some number that's not really going to make a damn bit of sense if it didn't, right? That's all you get back if you use a system, which again might be fine for you. Whereas with popen, you can send a command to the operating system, you can get the response back that you can assign to a variable value, and then once you have that variable value, then you can do the if-else statements and try to do something a little bit more sophisticated, right? So the OS module allows you to interact with that underlying operating system to do some very cool things. Again, do not reinvent the wheel. You do not have to figure out how to create a ping application on your own. Ping has existed for like 50 years. Just use the one that already exists. It's going to be better for everybody, right? And that's the thing. That's what's so great. There's a lot of, especially in the Linux world, one of the reasons why Linux is so popular with coders in the modern world is that so many of the apps and the application software were built for command line by default, right? So Linux has been like one of the top operating systems for servers for 30 years at this point. Most of the times when you're running servers, you don't really want that graphical user interface because that's additional resources, that's additional security issues that you have to worry about. You just want command line, right? Command line. So type in a command, get a text response back. And so one of the things in the Linux world is that's how Linux has been designed for 30 years. So there are a tremendous number of command line applications that you're able to access using the OS module that you might not be able to access again in the Windows world. If you want to do scan a network, right? The first time that you see Nmap, so Nmap is a network scanning utility for Linux, right? And when you run it, again, you type in a whole bunch of text and then you get a whole bunch of text back. And so when you're new, right, that seems really scary. That seems really intimidating. I'd rather go to Windows and use Spiceworks or SolarWinds or some nice, pretty graphical user interface in order to scan my network, right? And that makes sense, right? Double click, right click, left click. That's a lot easier way to comprehend doing network scanning than literally having to type in these ugly ass commands and then getting even uglier results back. But here's the thing. Once you're able to use Python to trigger those commands, basically have values be dynamic because you're now dumping in variable values instead of things that you manually assigned. You're able to bring back the response. You're then able to parse it based off of whatever you're interested in. Once you've parsed it, you can then print that into an HTML web document and host that somewhere on Apache or Nginx web server. You can take that information, you can dump it into a database somewhere. So you could track things like the network monitoring results over years to see what's happening on your network, different things like that, right? That's what makes things like the OS module really, really cool. And it also starts to show you the real power of the Linux operating system and why, again, Linux and Python Python really is a valuable skill set to have in this modern world. Um, do you remember with this? Again, you're dealing with the operating system. So security and privileges is all on you. I have no idea what your operating system looks like, so don't even ask me, right? If you're trying to run this stuff against the operating system, basically your script will be running as some type of user account, right? It will have permissions based off of its user account and its group, so it will run based off of those permissions. What the hell you have set up on your computer, that's a whole series of classes for another day. And so again, that's one of those things that you just kind of have to keep in mind. And then finally, again, using the OS module, there is a different module out there called the sub-process module. We'll probably have a class on that later. It's a great module. In many ways, it is better than the OS module, but I was showing you this because this is in line with what I've already taught you, is very simple to understand. And so I think we'll make this whole, you grasping what we're trying to do here a little bit easier. Again, in the real world, think about your environments, think about what problems that you're trying to solve for, and then use the technology that's most appropriate. Is sub-process most likely what's most appropriate in a production environment? Yeah, most likely. But again, with everything that I've shown you, I think this is an easier way to bring you into this world of using the operating system. And so that's why we've gone down this route. Is it the right decision? I don't know. I don't know. We'll find out later. So anyways, that's all I've got for you today. As always, I enjoy teaching this class and look forward to seeing the next one.